We've been taught one simple rule in modern gardening. Feed the plant. Nitrogen, phosphorus, potassium, granules, liquids, bags with promises printed on them. But what if I told you we've been aiming at the wrong mouth this whole time? Old farmers didn't talk about NPK. They talked about soil. They understood something we forgot when chemicals took over. Plants don't eat fertilizer directly. Plants eat what the soil life prepares for them. In your hand, I'm holding a jar of thick, black molasses. It looks like sugar, it smells like sugar, and to plants alone, it means almost nothing. But to the invisible world beneath your feet, this is a feast. In 1 teaspoon of healthy soil, there are more living organisms than there are people on Earth. Bacteria, fungi, protozoa, tiny workers that mine minerals, unlock nutrients, and deliver them straight to plant roots. And right now, in most gardens, they are starving. Today, we're not feeding plants, we're feeding the underground workforce. And when you feed them sugar, roots respond fast.
To understand why a spoon of molasses can transform your garden, you have to stop thinking of soil as dirt and start seeing it as a living farm. Beneath every healthy plant is an underground city. Bacteria are the factory workers. Fungi are the transport network. Protozoa are the regulators that keep populations in balance. Together, they do one job. They cook food for plants. Plants cannot simply grab raw minerals from soil particles. Phosphorus is locked up. Calcium is bound. Trace elements are trapped in forms roots cannot absorb. This is where microbes come in. They secrete acids, enzymes, and compounds that dissolve minerals, chew through organic matter, and convert it into bioavailable nutrition. Think of them as tiny chefs standing between raw ingredients and the dinner plate. But chefs don't work for free. They need energy, and that energy is carbon, sugar. In nature, plants already know this. Through their roots, they leak sugars, amino acids, and carbohydrates into the soil. These are called root exudates. It's not an accident, it's a bribe. The plant is saying, "I'll feed you, now work for me." Healthy plants may send up to 40% of the sugars they produce straight underground. That's how important this relationship is. But modern gardening breaks this deal. When soil is compacted, sterile, or constantly blasted with synthetic fertilizers, microbial life collapses. There's no organic matter to process, no reason for microbes to stay active. The underground kitchen shuts down. So the plant struggles. Roots grow shallow. Nutrients wash away. We add more fertilizer. The cycle repeats. This is where molasses enters the story. Molasses is not fertilizer in the traditional sense. It contains almost no usable NPK. What it contains is simple, fast carbon, pure energy for microbes. When you pour diluted molasses into soil, you're not feeding the plant, you're waking up the workforce. It's like turning on the lights in a factory that's been running on emergency power. Bacterial populations can explode by hundreds or even thousands of percent in 24 to 48 hours. Fungal networks become more active. Nutrient cycling accelerates. Suddenly, minerals that were present but unavailable start moving toward roots, and the roots notice. They respond by branching, thickening, and producing more fine white feeder roots, the kind responsible for real nutrient uptake. This is why gardeners often see stronger root systems after using molasses, even though the liquid itself contains almost no nutrients. You didn't feed the plant, you fed its herd. This is why old farmers used sugar sources long before microbiology had names for these organisms. They didn't need microscopes, they watched results. Healthier plants, better resilience, richer soil year after year. Molasses is not magic, it's biology remembered. And once you understand that you're not pouring sugar on dirt, but feeding millions of tiny helpers who work for your plants day and night, the entire garden starts to make sense.
This is the moment where most people ruin everything. Not because the method is complicated, but because it looks too simple. And when something looks simple, we tend to overdo it. Sugar feels harmless. Molasses feels gentle. And that's exactly why people pour too much. So let's slow down and do this the way old farmers and living soil actually want it done. What you're making here is not fertilizer. It is a controlled energy drink for microbes. And like caffeine, the dose matters. Start with water. Not cold, not hot. Warm, about the temperature you'd wash your hands in. Warm water dissolves molasses properly and wakes microbes faster. Cold water just lets it sink to the bottom and clump. Now the sugar source. The best option is unsulfured blackstrap molasses. Not because it's trendy, but because sulfur dioxide, used as a preservative in some molasses, can suppress microbial life. If you don't have blackstrap, plain unsulfured molasses is fine. In a pinch, brown sugar will work. Even white sugar works, though it lacks trace minerals. Remember, the microbes don't care about branding. They care about carbon. Now the ratio, and this is the rule that protects your soil. 1 to 2 tablespoons per 4 liters, 1 gallon of water, no more. That's it. This is where ego kicks in. People think if 1 spoon is good, 3 must be better. No, 3 spoons can feed the wrong organisms. 4 spoons can invite fungal imbalances. 5 spoons can turn your soil into an ant highway. You are feeding a herd, not flooding a city. Stir the molasses thoroughly into the warm water until it completely disappears. Take your time. You want a uniform solution, not syrup pockets. Once dissolved, pour it into your watering can or sprayer. And now, the most important rule of all. You water the soil, not the leaves. Sugar on leaves is an invitation. Ants, aphids, mold, mildew. You are not feeding the plant directly, so there is no reason for sugar to touch the plant itself. Aim for the root zone. Slow, even watering. Let it soak down where the underground workers live. This works best when microbes already have something to chew on. That means organic matter, compost, mulch, old roots, decomposing material. Molasses does not create food, it accelerates digestion. That's why this method shines when paired with compost tea, worm castings, or organic amendments. You're not just feeding workers, you're stocking the kitchen and turning on the lights at the same time. One more thing that surprises people: frequency. This is not a weekly ritual. This is not every watering. Once every 2 to 4 weeks is plenty. Microbial populations spike fast and then stabilize. Constant sugar dosing can create dependency and imbalance. Healthy soil should run mostly from plant exudates, not constant outside stimulation. Think of molasses as a jumpstart, a seasonal boost, a way to wake tired soil, not keep it wired forever. When done correctly, nothing dramatic happens immediately above ground. No overnight miracles, no cartoon growth. The real action is invisible. And that's exactly how you know you're doing it right.
This is the part where we slow the excitement down, on purpose, because molasses gardening sits right on the edge between real biology and internet hype. And if you cross that line without understanding what's actually happening underground, you can do more harm than good. So, let's clear the fog. The biggest myth sounds innocent, but it's dangerous. Molasses is a fertilizer. It is not. Molasses contains almost no usable nitrogen, phosphorus, or potassium. You could pour a whole bottle into dead sand and nothing would grow. No leaves, no roots, no miracle. What molasses does is wake up workers, not create food. Think of your soil like a factory. Organic matter is the raw material. Microbes are the workers. Molasses is the coffee break bell. If the factory is empty, no compost, no mulch, no decaying roots,
then all you've done is make hungry workers angry. You increase microbial demand without increasing supply. And when microbes get desperate, they start competing aggressively. That's when imbalance begins. Which brings us to the second danger. Too much sugar feeds the wrong crowd. Beneficial bacteria love simple sugars, but so do opportunistic fungi, molds, and pests. In a balanced soil, good microbes keep the bad ones in check, but overdose the system and you tip the scale. That's when people report white fungal fuzz on soil, sour or rotten smells, explosions of ants, sudden aphid pressure. Not because molasses is bad, but because biology always obeys supply and demand. Ants, in particular, are excellent indicators. If ants show up in force, your soil is telling you something. Too sweet, too fast. Another myth needs to be addressed honestly. This will work in any soil. No, it works best in living soil. If your garden is heavily sterilized by chemicals, compacted, or stripped of organic matter, molasses alone won't resurrect it. You must rebuild habitat first: mulch, compost, leaf litter, cover crops. Molasses is a booster, not CPR. And then there's the timing mistake. People use molasses constantly, every watering, because the results feel addictive. Leaves perk up, plants look happy, growth accelerates. But biology hates constant stimulation. Microbial populations spike fast, then crash. Overstimulation leads to dependency, imbalance, and eventual burnout, just like people living on caffeine alone. That's why the old farmers didn't use this daily. They used it strategically. Once every 2 to 4 weeks, during transplant shock, in tired beds, after heavy rain, when soil biology needs a nudge, not a shove. Here's the grounding truth that keeps this technique powerful. Molasses does not replace compost. Molasses does not replace mulch. Molasses does not replace patience. It amplifies what is already there. Used correctly, it creates cooperation underground. Used blindly, it creates chaos. And that leads us to the most honest comparison of all. Molasses is like coffee for humans. It wakes you up, it sharpens focus, it boosts performance. But drink only coffee and skip real food, and eventually you collapse. Feed your soil real meals first, then use sugar as encouragement. That's where the magic stays real.
This is the moment where the soil starts talking back. Not in words, but in signs that are hard to miss if you know what to look for. Within the first 24 to 48 hours, the underground world wakes up, microbial respiration increases, enzymatic activity rises, and nutrient cycling accelerates. You won't see bacteria with your eyes, but you will see their effects. The first visible change is plant posture. Leaves that looked tired or slightly droopy regain firmness. The plant doesn't suddenly grow taller overnight, but it looks awake. This is leaf turgor, water and nutrients moving more efficiently through cell walls. It's the same difference between a thirsty person and someone fully hydrated. Then comes color. Leaves often deepen into a richer green, not from added nitrogen, but from improved nutrient availability. Elements already present in the soil, locked away, suddenly become accessible because microbes are doing their job faster. But the real transformation happens where most gardeners never look, in the roots. If you pull up a plant carefully a few days later, or compare seedlings grown with and without molasses, the difference can be dramatic. Instead of a few thick roots, you see dense networks of fine white root hairs. These are the absorptive roots. This is where water, minerals, and life enter the plant. More roots mean more surface area. More surface area means more resilience. More resilience means better growth, better yields, and better recovery from stress. This is why molasses works so well during transplanting.
When a plant is moved, its root system is damaged. Feeding the soil microbes helps rebuild that underground network faster, reducing shock and stall-out. It's also why this technique shines in tired soil, beds that have been planted year after year, where growth has slowed and harvests feel weaker. You're not forcing plants to perform, you're rebuilding the support system beneath them. This isn't a miracle, it's biology catching its breath.
You don't have to believe me. You don't need faith. You don't need theory. You need one simple test. Buy a jar of molasses from the grocery store. Water half of one bed with sugar. Water the other half with plain water. Then watch. Watch which plants recover faster, which ones root deeper, which side stays greener longer. Those invisible workers beneath your feet, your underground pets, your tiny chefs, your microbial herd, will answer for me. Feed them once in a while, treat them well, and they will repay you with roots you can't see and harvests you can't forget.
Modern gardening teaches us to think in bags and bottles. Nitrogen for leaves, phosphorus for roots, potassium for fruit. Measure, pour, repeat. But today, I'm not holding fertilizer. In one hand, I have a piece of copper wire. In the other, a simple galvanized zinc nail. And between them, nothing special, just soil, wet soil. Now here's the strange idea. What if your garden bed isn't just dirt? What if it's already a giant battery, quietly waiting to be switched on? You already have the electrolyte, that's moisture in the soil. You already have the medium, that's minerals and organic matter. All that's missing are two different metals and a connection. 100 years ago, this wasn't called a hack. It was called an earth battery, sometimes galvanic gardening. Old agricultural books claimed it could speed growth, strengthen roots, and increase yields without adding fertilizer at all. Modern science mostly shrugs and says, nonsense. So today, I'm not here to argue theory. I'm a gardener, not a physicist. We're going to plug the garden into itself and see what actually happens to real plants in real soil. If this works, it means growth doesn't only come from a bag. If it fails, then at least we'll know where myth ends and biology begins. Either way, the soil will answer.
Let's strip the mystery away before it turns into magic. An earth battery is not mystical. It's not wireless energy. It's not science fiction. It's a high school experiment scaled up. You've probably seen it before. A potato, two different metals, a small voltage reading on a meter. The potato isn't the power source, it's just the medium. Your garden bed works the same way. When you push two different metals into moist soil, for example copper and zinc, you create a basic galvanic cell. One metal acts as the anode, the other as the cathode. Because they have different electrical potentials, electrons want to move. So they do. The soil, rich in moisture and dissolved minerals, becomes the electrolyte. Electrons begin to flow through the wire connecting the metals, and suddenly your dead dirt is part of a very weak electrical circuit. We're not talking lightning, we're not talking danger. This is tiny energy, usually around 0.5 to 1 volt, less than an AA battery, barely enough to register unless you're a living system. Plants are not passive objects. Their roots use electrical signals constantly to guide growth, manage ion exchange, and regulate water uptake. Root tips generate natural electrical gradients as they move through soil. This is how plants decide where to grow next. The theory behind galvanic gardening is simple. That weak, constant electrical field slightly alters ion movement in the root zone. Minerals become more mobile. Water uptake becomes more efficient. Root membranes become more active. It's not forcing growth, it's nudging physiology, like giving the roots a gentle wake-up call instead of a chemical shove. Some researchers argue the effect isn't electricity at all, that it's micronutrients slowly released as metals oxidize.
Others believe it's a combination of both, trace elements and electrical stimulation working together. And honestly, from a gardener's perspective, the debate matters less than the result. If a tomato plant develops deeper roots, if leaves turn darker green, if growth speeds up without added fertilizer, then the soil is responding to something real. So, in this video, when I say earth battery, I'm not talking about magic wires. I'm talking about a controlled interaction between metal, moisture, and living roots. The question isn't whether electrons move. They do. The real question is whether plants care enough to change how they grow. And that's what we're about to test.
Now let's get our hands dirty, literally. Because this is where the forbidden technology stops sounding mystical and starts looking almost embarrassingly simple. No lab coats, no solar panels, no secret government parts, just two metals and the soil you're already standing on. Here's everything you need. First, copper. Not magic copper, not purified monk-blessed copper. A scrap of copper pipe, a thick bare copper wire, even an old grounding rod will do. Second, zinc. The easiest way? A galvanized nail or bolt. If it's dull silver and says galvanized, you're holding zinc-coated steel. Perfect. That's it. Two metals. Different personalities. That's important. Now, let's place them. Choose one healthy plant, not your whole garden, one tomato, one pepper, one experiment. Step back about 10 to 15 centimeters from the stem on one side. Push the copper straight into the soil. Then move to the opposite side of the plant. Same distance. Push in the galvanized nail. Depth matters. You don't want the surface, you want the root zone. About 15 to 20 centimeters deep, where moisture lives and chemistry actually happens. Now comes the moment that makes this feel illegal. Take a simple copper wire, strip the ends, nothing fancy. Wrap one end tightly around the copper rod. Wrap the other end around the galvanized nail. And just like that, you didn't power the plant. You completed a circuit. There's no switch, no button. The soil itself becomes the electrolyte. The moment those metals touched wet earth, electrons started moving, slowly, quietly, constantly. If you want proof, and this is where we become scientific, grab a cheap multimeter. Touch one probe to the copper, the other to the zinc. There it is. Not imagination, not belief, voltage. Usually somewhere between 0.5 and 1 volt. Tiny, but alive. And remember, plants evolved with lightning, magnetic fields, and underground currents long before fertilizers came in bags. So the real question isn't, can electricity exist in soil? The real question is, what does the plant do when it feels it? That's where things get interesting.
Now this is the moment where the comments section wakes up, because someone always says it. This isn't electricity, it's just chemistry. And honestly, they might be right. Let's slow this down and look at what's really happening underground. That galvanized nail you pushed into the soil? It doesn't stay shiny forever. Moist soil, oxygen, time. The zinc coating slowly oxidizes, and when it does, tiny amounts of zinc ions enter the soil. And here's the inconvenient truth. Zinc isn't poison. Zinc is a micronutrient. Tomatoes need it. Corn needs it. Most vegetables struggle without it. Zinc plays a role in enzyme activity, hormone production, and leaf development. Without enough zinc, plants stay small, pale, and stubborn. Now let's look at the other side of the circuit. Copper. Copper has been used in gardens for centuries, not for energy, but for protection. It suppresses fungal growth. It interferes with spores. It quietly cleans the underground environment. So the skeptic's theory goes like this.
There is no magic current waking up the roots. You're just feeding zinc very slowly and disinfecting the soil with copper. In other words, a long-term, ultra-slow fertilizer drip powered by corrosion. No mystery, no forbidden science. Just chemistry doing chemistry things. But here's where the argument starts to wobble. Because if this were only chemistry, then disconnecting the wires shouldn't matter. But many gardeners notice something strange. When the wire is removed, the effect weakens. Growth slows, leaf color fades. Something changes. So what is it? Electricity? Micronutrients? Or both working together? Maybe the current helps roots absorb zinc more efficiently. Maybe it changes ion movement in the soil. Maybe plants respond to electric fields the way animals respond to gravity. Or maybe we're arguing about the wrong thing. Because if the plant grows stronger, greener, faster, does it really matter why? The soil doesn't care about debates. Plants don't read research papers. They only respond. And in the next part, we stop theorizing and look at what actually happened in the garden. So what actually happens when you do this? Not in theory, not in old books, but right here in the garden. When you place two identical plants side by side, same soil, same sun, same water, the difference becomes visible sooner than most people expect. The plant connected to the metals doesn't explode overnight. There are no miracles in 24 hours, but after a week or two, patterns begin to form. The leaves deepen in color, not brighter, darker, a heavier, richer green. Stems feel firmer, growth becomes steadier, not frantic. And underground, where you can't see, roots tend to spread wider and dig deeper, especially in soils that were tired or compacted. The control plant still grows, but it looks hesitant, like it's thinking about it. This doesn't mean the earth battery is magic. It means it's subtle. And subtle systems are the easiest to misuse. This is not something you install everywhere at once. Dry soil will give you nothing. No moisture means no movement, no chemistry, no current, no effect. Overly acidic soil is another risk. In those conditions, zinc can dissolve too quickly and overwhelm the plant instead of helping it. This is not a blanket solution. It's a test. One plant, one bed, one comparison. Gardening has always rewarded patience more than belief. You don't have to believe in earth batteries. You don't need old books. You don't need theories. You don't need permission. You need one nail, one piece of copper, and one plant you're willing to experiment on. This may be the cheapest experiment you'll ever run in a garden. Find an old galvanized nail, a scrap of copper wire, connect them, push them into the soil. If that one plant outgrows the others, you've learned something valuable. And if it doesn't, you didn't waste money. You didn't poison your soil. You spent time outside, touching the ground, asking questions. That alone already puts you ahead of most gardeners. Because real gardening doesn't start with answers. It starts with curiosity.
What if I told you that the most powerful fertilizer in the world is not sold in bags, not mixed in tanks, and not regulated by any company? What if I told you it's already here, surrounding us every second, invisible but constant, in the air above your garden? We all understand solar panels. We accept that sunlight can be captured, concentrated, and transformed into usable energy. But plants are already solar panels. They convert light, moisture, minerals, and subtle forces into growth, structure, and food. And about 100 years ago, some farmers believed they had discovered a way to amplify that natural process using nothing more than copper and wood. This forgotten practice is called electroculture. I'm not a physicist, I'm a gardener. I don't pretend to fully understand the equations behind magnetism, ions, or atmospheric charge. What I care about is simple: Does it work, and does it cost almost nothing? Today, we'll explore a story that sits right on the border between science, myth, and practical gardening, and you can decide for yourself where the truth lives.
To understand electroculture, we need to step back to France in the early 1920s, a time when electricity itself still felt mysterious, almost alive. Radios were new, power lines were spreading across the countryside. The air felt charged with possibility, both literally and culturally. In this moment appears a man named Justin Christophlo. Christophlo was not a university professor, not a corporate scientist, and not backed by any industrial power. He was an independent inventor, deeply curious about nature, and convinced that plants were influenced by forces most people ignored. Through years of observation and experimentation, he became convinced that atmospheric electricity, the natural electrical charge present in the air, could be collected and directed into the soil to stimulate plant growth. He designed simple devices, wooden stakes fitted with copper wire, spirals, and antenna-like structures. These devices were placed near crops, not connected to batteries, not plugged into any grid. According to Christophlo, they acted as collectors, drawing subtle electrical energy from the atmosphere and guiding it into the earth, where plant roots could benefit from it. The results, at least on paper, were extraordinary. Photographs from his books and pamphlets show cabbages so large they look unreal, towering over the people standing beside them. Peas with unusually thick stems, leafy vegetables with deep, dark coloration that suggested intense vitality. Christophlo claimed yield increases of 200 to 300%, faster maturation, and stronger resistance to disease. He didn't hide his work. He patented his devices, he published explanations, he demonstrated them publicly. For a brief period, electroculture was not fringe, it was debated seriously in agricultural circles. Then, quietly, it vanished. After World War II, agriculture changed direction completely. Synthetic fertilizers, pesticides, and industrial-scale farming promised predictability, profit, and control. These new methods were easy to package, sell, and standardize. A technology that relied on free atmospheric energy, copper wire, and farmer curiosity did not fit this new economic model. Electroculture was gradually labeled unscientific. Patents expired, research funding disappeared, Christophlo's name faded into obscurity. What remained were a few old photographs, scattered documents, and stories passed quietly between gardeners. Today, mainstream science often dismisses electroculture as pseudoscience, and to be fair, large-scale modern studies are limited. But here's the uncomfortable part. Thousands of gardeners across the world, independently, without coordination, continue to report similar results when they try it themselves. Darker leaves, faster growth, stronger plants. Is it atmospheric electricity? Is it copper ions? Is it microbial balance? Is it simply pest deterrence? I don't claim to know, but history teaches us something important. Not everything that disappeared was disproven. Some things simply became inconvenient. And that's where this story stops being about the past and starts becoming about your garden. Now let's move from history into practice. This is the moment where most people expect complexity, measurements, formulas, special tools. And this is where electroculture surprises you. The method is almost offensively simple. In the frame, you see only hands, a piece of wood, and copper wire. No electricity, no batteries, no plugs. If this feels too simple to be true, you're already thinking like a modern consumer, and that's exactly the mindset this technique challenges. First, the stick. Choose a wooden stick, natural wood, not painted, not treated, not plastic, not metal.
About the thickness of a thumb or wrist is perfect, but don't obsess over it. In traditional electroculture, wood is used because it is electrically neutral and does not interfere with the flow of subtle charges. Think of it as a spine, the structure that holds everything in place, nothing more. Second, the wire. Use bare copper wire. Remove all insulation. Copper matters here, not steel, not aluminum. Copper has been associated with plant health for centuries, long before modern chemistry explained why. Again, don't chase perfection. Thicker wire is fine. Thinner wire is fine. This system forgives mistakes. Now comes the part that feels almost ritualistic, the spiral. Start at the bottom of the stick and wind the copper wire upward in a spiral, always clockwise. This detail appears again and again in historical electroculture texts, and it's not random. Clockwise spirals mirror patterns found everywhere in nature: DNA strands, snail shells, vines climbing toward light, even galaxies. Whether this has physical significance or symbolic alignment, nobody can say with certainty. But when nature repeats a pattern, experienced gardeners pay attention. As you wind upward, keep the spiral loose and even. You're not strangling the stick, you're dressing it. Let the wire breathe. Let small gaps exist. This is not engineering, it's imitation of natural form. When you reach the top, leave a small tail of wire pointing upward into the sky. This antenna tip is important in electroculture tradition. It symbolizes and possibly functions as the connection point between Earth and atmosphere. You're not forcing energy downward, you're inviting it. Now, installation. Take the finished antenna and push it gently into the soil near your plant. Not directly on the stem, give the roots space. Traditionally, antennas are placed on the south side of the plant in the northern hemisphere, simply to avoid casting shade. But don't let this stop you. If your garden layout doesn't allow perfection, choose practicality. One antenna per plant is ideal for testing. This is important. Electroculture is not about blind belief, it's about comparison. Place an antenna near one tomato plant. Leave the neighboring tomato untouched. Same soil, same water, same sun. Let them compete quietly while you observe. And that's it. No chanting, no power source, no daily adjustment. Just copper, wood, soil, and patience. This is where skeptics usually laugh, and I understand why. It looks too easy, too cheap, too harmless to matter. But gardening has always rewarded those willing to test instead of argue. You don't need faith here. You only need curiosity. Because the real question isn't how elegant this looks. The real question is what happens next.
This is the moment where the story splits in two directions. On one side, you have believers. On the other, scientists, skeptics, and people who immediately say, "This is nonsense." And instead of choosing a side, I want to stand right here in the middle, where a gardener belongs. Let's start with the version that sounds like magic. Supporters of electroculture say that the copper antenna collects atmospheric electricity, weak electrical charges naturally present in the air, especially during changes in weather, humidity, and magnetic conditions. According to this view, the spiral shape acts like a receiver. The antenna channels these subtle energies down into the soil, stimulating root activity, sap movement, and nutrient uptake. In older electroculture texts, this energy is sometimes called ether, sometimes telluric currents, sometimes simply life force. These terms make modern scientists uncomfortable, and understandably so. They belong to a time before we had precise instruments, when people described effects before they could explain them. But here's the uncomfortable truth. Plants do respond to electrical and magnetic fields.
Roots grow differently when exposed to weak currents. Ion movement in soil affects nutrient availability. Atmospheric electricity is real. Lightning is just the dramatic version of something that is always present. So the idea itself is not completely insane. It's just poorly measured. Now let's switch lenses and look through the eyes of a skeptic. Modern science offers a much more grounded explanation. Copper is not just a metal, it's biologically active. Copper has been used for over 100 years as a fungicide in agriculture. Bordeaux mixture, one of the oldest plant treatments in history, is copper-based. So what if the antenna works not because it pulls energy from the sky, but because tiny amounts of copper ions slowly enter the soil? These ions can suppress harmful fungi and bacteria around the root zone. Less disease means stronger plants. Stronger plants grow faster, with darker leaves and thicker stems. No magic required. There's more. Slugs and snails absolutely hate copper. When they touch it, a small galvanic reaction occurs between their slime and the metal, creating a mild electrical shock. They retreat instantly. So a copper spiral near the base of a plant may act as a silent guard, reducing pest damage without poison. And then there's the placebo effect, not for plants, but for gardeners. When people experiment, they observe more closely, they water more thoughtfully, they compare, they care. Better care alone can improve results, and skeptics love to point this out. So which explanation is correct? Is electroculture atmospheric electricity? Is it ion exchange? Is it pest control? Is it coincidence? Here's my honest answer, and this is important. I don't know. I'm not a physicist. I'm not an agronomist in a white lab coat. I'm a gardener. And gardeners have always judged methods by one brutal standard. Does it work in soil, not on paper? If copper antennas consistently show darker leaves, faster growth, and earlier harvests, then the mechanism becomes a secondary question. Humanity used compost long before microbiology explained bacteria. Farmers rotated crops long before nitrogen cycles were understood. Understanding often comes after success. So instead of asking, is this magic or science, I prefer a simpler question. If this costs almost nothing, harms nothing, and might help something, why wouldn't we test it? In the end, plants don't care about our debates. They only respond to conditions. And the soil never lies.
So what actually happens when you put a copper antenna into the ground? Let's be very clear. Not promises, not legends, but what gardeners around the world consistently report. First, growth speed. Tomatoes tend to flower earlier and set fruit sooner. The plant doesn't necessarily become taller overnight, but it becomes busier, more side shoots, more leaf surface. The growing season feels slightly accelerated, especially in cooler or unstable weather. Second, leaf color and structure. One of the most repeated observations is darker, thicker foliage. Leaves look more charged, more alive. This usually indicates improved nutrient uptake, whether through healthier roots, reduced fungal pressure, or better ion movement in the soil. Third, resilience. Plants near copper antennas often appear less stressed during heat waves or short dry periods. This does not mean they no longer need water. It means they seem to cope better with fluctuations, bouncing back faster after stress. But now comes the part most viral videos never tell you. This is not a magic wand. If your soil is dead, compacted, and dry, the antenna will not resurrect it. If you forget to water, ignore pests, or plant at the wrong time, copper will not save you. Electroculture is not a replacement for gardening. It is a booster, not an engine. Think of it like this.
If good soil, water, and sunlight are the foundation, the antenna is a small tailwind. You still have to pedal, but pedaling gets easier. And that's exactly why this experiment matters. Because unlike fertilizers, chemicals, or complicated systems, this costs almost nothing. No subscriptions, no refills, no dependency. Just copper, just curiosity.
You don't need to believe me. You don't need to argue in the comments. You don't need to choose a side. Copper wire costs pocket change. Make one antenna, place it next to one plant, leave another plant exactly as it is. Same soil, same water, same sun. Let the season decide. And when autumn comes, come back here and tell us which plant grew stronger. Because in the garden, truth doesn't come from opinions. It comes from results.